We've seen that a z-score is how many standard deviations am I from the mean. And this z-score in combination with the idea of probability can be used to say, what's the chance of seeing certain values? Recall that probability is how frequently or what's the proportion that an event occurs in a long run of experiments. And this will be important when we think about the idea of a p-value and later on when we do our idea of confidence intervals as well. Probability is always between 0 and 1, and we can think of it now in terms of what's the probability of seeing an individual value in a distribution. This is important when it comes to z-scores because we're often trying to put categories or definitions onto a naturally occurring range. So we've talked about bone mineral density, and bone mineral density on the average is average, but it could be high and it could be low, and it follows a normal distribution. At some point, we might say that there is a having too low has some clinical effect. Where do we draw that line? Well, if we take a bunch of healthy young women and we look at their bone mineral density, we might see a distribution like this. And if we look at women with low bone mineral density, we can draw a line, let's say 2 standard deviations below the mean. And that would define these people as being sick or having a disease or being eligible for a certain type of treatment. It's interesting that this line is maybe somewhat arbitrary. God didn't come down and she didn't hand us a thing that says -2 z-score and below is this disease. This is defined by someone. And we'll think often about who has the power to define diseases and treat diseases and so on. There's an interesting story that was run on NPR, which is called How a Bone Disease Grew to Fit a Prescription. And it's a story about a new drug that comes out that can help preserve bone mineral density. And if you say you wanted to sell that drug, and here's your market right here, how could you increase the number of people who want to have that drug? Well, you can make more people sick. How do you make more people sick? Is you draw a new line and you make a new disease. And this is the idea of osteopenia. And if your bone mineral density is more than 1 standard deviation below the mean, this huge swath of population here, you are now sick and you are now eligible for treatment or considered for treatment for osteopenia. We see this all the time, a continuous, naturally varying characteristic where then lines are drawn and people are labeled, people are treated, and so on. We define obesity that way in the US, a distribution of kids from the 1970s, some overweight, some underweight, on the average, most of them average. And we calculate their BMI, and it's turned into what's called the BMI z-score. And when you look at those kids from the 70s, the distribution looks something like that. Most kids are average, and maybe about 2.5% of the kids are above 2 standard deviations. What we do today is take current kids and we put their distribution on top of that, something like this, and anyone who is above the 85th percentile gets this label. Anyone who is above the 95th percentile gets this label, and then treatment occurs from there. So be on the lookout for any continuous characteristics that get labeled and ask yourself why and how. I saw this recently at the YMCA, this new idea of pre-diabetes. We might look at, say, fasting blood sugar and look at the natural range that occurs amongst people. The idea of pre-diabetes might be people who are here. They don't have diabetes yet, but if things continue, then they might be up here in this higher part of the curve, which is interesting because if you had diabetes and they treated it and you did a great job and you ate well and you exercise and you adhere to everything, then you come back down in here and now you have pre-diabetes. You're destined to get it again. So be on the lookout for this and try to think of an example. What is something that's continuous variable that then gets labeled into categories? Why and how does that happen? Here is just a summary of what we've talked about with the normal distribution. We see the percentages that fall in certain ranges here. So there's our most people falling within one standard deviation. If we take that in terms of percentiles, you can see here, if you score in the 99.9th percent on a test, you're at the third standard deviation. Certain scores, I think these have changed since this slide's been updated, has been made, but certain test scores fall on these certain range. And it can be really useful to try to look for an example of a normal distribution where then people get referenced using either z-scores, percentiles, or some sort of scoring like that. That's all for z-scores. Talk to you soon. Thank you.